Okay, so we are finished about chapter 3, key technologies. Let's continue with chapter 4, technical specifications. So actually, our WDM is a very good technology. A lot of different countries, a lot of different companies like to use this technology in their own places, own equipment. But if we don't have any standard for this technology, then I think the different company, different country cannot connect with each other. So that makes this technology very hard to use it. So our ITUT department will give us technical specifications, so give us different rules for different parts. Check this out. G.652, G.653, G.655, I think you are familiar with it. That defines the fiber for our WDM network, okay? Single mode fiber, okay? For the G.652 defines optical interface for multi-channel system with optical amplifier, okay? G.654.1 and 4.2 defines the DWDM frequency and CWDM wavelengths can be used in our WDM network, okay? And the G.975 is define the forward error correction for the submarine system. That's FEC, forward. How do we use it? Okay. And the last very important one is G.709. That's interface for the optical transport network. That is OTM protocol. It's a layer 2 protocol. Okay. You know, WDM technology is a layer 1 technology. It's working in a physical layer. Okay. But after we use WDM technology to transmit the service, I think we need some overhead to monitoring the service quality, to do the OAM, to check the bit error, right? So OTM protocol already give us this standard, told us how do we use overhead, what's the function of this overhead to monitoring your system. That's all be defined by G.709. OTM protocol. Okay. Okay. Two standardized optical interface parameters. The ITUT G.692 defines all reference points of the WDM optical transmission system, just like those black points in this picture. As you see it like this way. Okay. And for S1 to Sn, that the reference points of channels 1 to N on the optical fiber at the optical output connectors of transmitters. RM1 to RMN reference points of channels 1 to N on the optical fiber at the optical input connectors of an OM or OA. MPIS, MPI means main path interface. Reference point on the optical fiber behind the optical output connectors of an OMOA. S and R reference point on the optical fiber before the optical input or output connectors of a line output optical amplifier. Okay. MPIR reference point on the optical fiber before the optical input connectors of an OM or OD. And SDI to SDN reference points at the optical output connectors of an OA or OD. R1 to Rn reference points at the optical input connectors of receivers. Okay, so what's the function of these reference points? In the future, maybe you want to check the performance in different points, the performance of our network. Maybe you can see some performance in the document, technical document, right? At this time, he will show you the performance, for example, the performance for MPIS point. So you should know what is MPIS point. Okay, what's the meaning of this one? This is a reference which port, right? Which part? It's like this way. So which kind of WDM frequency we can use for our WDM network? I think it's already been defined in G.694.1 ITUT, already give our standard. Okay, actually for this kind of the frequency has 3 different channel spacing: 100 GHz, 50 GHz, or 25 GHz. Actually, in our DWDM, we have 2 different types. We call it traditional WDM and NGWDM. NGW means new generation WDM. For the traditional WDM, we are still using 25 GHz spacing. But for new generation WDM, NGWDM, we are only use 100G, 50 GHz now. Why did we use these two now? Not to use 25 GHz anymore. Because 25 GHz spacing is too small for your service. If the spacing between two wavelengths is too small, then every wavelength cannot use to carry very high bit range service, such as 40G, 100G. The maximum wave, wavelengths, the maximum bit range can carry by the wavelengths is 10G if the spacing is only 25 GHz. Okay, so in NGWDM we like more wavelengths and more capacity for each wavelength. So we choose 100 GHz and 50 GHz. Okay, so let's introduce them. If we use the 50 GHz, the frequency we can use is from 192.10 GHz to 196.05 GHz. The space between each wavelength is 50 G. 50 GHz. This means 0.05 THz. You can do a math calculation. You can got 80 wavelengths. 80 wavelengths can be used. But someone saying, I don't want to use 80. I only want to use 40 wavelengths. It's enough for me. So you can choose this 100 GHz spacing. You will got 40 wavelengths. 40 wavelengths in C-band in 50-50 nanometers array. So this wavelengths could be 192.10 THz to 196.0 THz. The spacing between two wavelengths also 100 GHz. You have got 40 wavelengths. This wavelengths we also give it a name because C even EVEN. And actually you can someone will no. If it's 40G, 50G, we got 80. If it's 100G, we got 40. So if we cut this 40 wavelengths from this 80 wavelengths, you will another 40 wavelengths. That is from 192.15 THz to 192.605 THz. The spacing also 100G. Okay, this 40 wavelengths we call it COD, CODD. Okay, COD frequency. Okay, so that's the wavelengths we can use. 100G, two different 40 wavelengths. 50G, 80 wavelengths. 25G, you can go to 160, but the wavelengths spacing is too small, cannot use to carry very high bit range service. Only used for maximum is 10G. Okay, so that's the wavelengths we use in CWDM and DWDM. Okay, so let's check the question for our chapters. What is absolute reference frequency of an optical WDM system? What is the channel spacing? I think the answer is very clear. The absolute reference frequency is 193.1 kHz. We can check from the last cycles. And the channel spacing has three different types: 100G, 50G, and 25G. Okay, so let's do the summary. We will learn the WDM overview. In these chapters, we learn the WDM structures. We know what is CWDM, we know what is DWDM. We know the advantage of our WDM knowledge, right? And then we will learn the transmission media. We know the fibers we used in our WDM network, a lot of different type. And we know the features of this type: PMD, chromatic dispersion, and attenuation, right? And also we learn the key technology of our WDM network: optical source technology, amplifier technology, mounting planks, demounting planks technology, and supervisory channel technology, right? Then we learn the technical specifications. We know the frequency spacing used in our wavelengths, okay, DWDM wavelengths, 50G, 100G, 25G spacing, okay, and we know the G point and a lot of different standard by ITUT department, right? So that's what we learned in this course. Thank you, guys.